So we're finally looking at applications or real-world problems involving systems of inequalities. So I went ahead and rewrote the problem down, started with a coordinate system over here for our graph, and I've underlined some key material, some key items in our problem. We're told that a trailer can carry a maximum weight of 160 pounds and a maximum volume of 15 cubic feet. A microwave oven weighs 30 pounds and has 2 cubic feet of volume, while a printer weighs 20 pounds and has 3 cubic feet of space. So I underlined the weights and the volumes for each of these. So first off, let's define our variables. I'm going to go ahead and call M equals the number of microwaves, and let P equal the number of printers. Then we can set up a system of inequalities, one based on weights and one based on volume. So let's look at weights first, since that comes first. We're told that a microwave oven weighs 30 pounds and a printer weighs 20 pounds, and we know the total of weight can't be more. It has to be less than or equal to 160 pounds. So 30 times the number of microwaves, M, plus 20 times the number of printers, P, has to be less than or equal to 160. And now we just apply the same thing to the volumes. We know that 2 cubic feet per microwave, so 2 times the number of microwaves, plus 3 cubic feet per printer, so 3 times the number of printers, has to be less than or equal to a total volume of 15 cubic feet. Now, we don't have to. This is a perfectly acceptable response for write a system of inequalities to model this situation. But if you'll notice, there's a common factor of 10 in that first inequality, and it'd be a lot easier to graph without it in there, so I'm going to divide both sides of this inequality by 10 to give me 3m plus 2p is less than or equal to 16. Now, as always, I like to put these in terms of slope-intercept form. In this case, it's a little ambiguous because we don't know, well, which is the input and which is the output. It doesn't really matter, but I'm going to assign, in order to graph, I'm going to assign the x-axis, so the x values are going to be represented by m, and then the p values are going to represent y, our outputs. So I'm going to go ahead and solve for y in both cases in order to graph this. Solve for p, in other words. So 3m plus 2p is less than or equal to 16. If we subtract 3m from both sides, we get 2p is less than or equal to negative 3m plus 16. And then dividing both sides by 2, we get p is less than or equal to negative 3 halves m plus 8. So if m equals 0, we can have a maximum, if there are no microwaves, we can have a maximum of 8 printers by our weights. So 1, 2, 3, 4, 5, 6, 7, 8. If there's 2 microwaves, that's negative 3 halves times 2 is negative 3, plus 8 is 5, so 2, 5. 1, 2, 1, 2, 3, 4, 5. If there are 2 microwaves, we can have 5 printers. And if there are 4 microwaves, negative 3 halves times 4, that's negative 6, plus 2, or plus 8 is 2. So 4, 2. 1, 2, 3, 4, 1, 2. And again, our scale here is just 1 for each tick mark. Now we combine, and it's an inclusive inequality, so we draw a straight solid line. And then we test a point. I'm going to test, as always, 0, 0. Using our original inequality, we want to know 2 times 0, or excuse me, 3 times 0. Because our original inequality is 3m plus 2p is less than or equal to 16. So 3 times 0 plus 2 times 0. We want to know, is that less than or equal to 16? That's 0, so it is indeed less than or equal to 16. So we want to shade the side that has 0, 0. So this left-hand side of the line. And then we'll move on to our second inequality. I'm going to go ahead and change the color for clarity's sake. So we have 2m plus 3p is less than or equal to 15. And again, you don't have to put it in slope-intercept form. That's just a preference for me. It makes it easier to graph, and that way it makes it easier to plot 3 points as well, instead of just using 2. And as a general rule, unless I'm strapped for time for some reason, I want to graph 3 points just to make sure that I haven't made a mistake. So again, if I solve for p, this is 3p is less than or equal to negative 2m plus 15. And then p is less than or equal to negative 2/3 m plus 15 divided by 3 is 5. So our p or y-intercept is going to be 0, 5. If I'm at 3, negative 2/3 times 3 is negative 2 plus 5 is 3. So 3, 3. 1, 2, 3. 1, 2, 3. And let's go ahead and go with 6, because if you'll notice, I'm multiplying by multiples of 3, so I can get rid of the denominator. So negative 2/3 times 6, that's negative 4 plus 5 is 1. So 6, 1 is our next point. So 4, 5, 6, 1. It looks like all 3 points do line up, so that helps verify that I've done everything correctly. Again, it's a solid line because it is inclusive. I'll test the point 0, 0. So 2 times 0 plus 3 times 0, is that less than or equal to 15? It is indeed. So we shade the left side of this line. So if you notice, what is shared is this section right here. And this would be the solution to the system of inequalities. Anything in here, although below the x-axis or the m-axis and below or to the left of the p-axis, that doesn't make sense. So technically the solution is just this positive area in here. It's not going to include, the positive area in here. It's not going to include any negative values, because you can't have negative amounts of microwaves or negative amounts of printers. So it's just this area inside that I just shaded the outline for, because the others don't make sense, because we can't have negative printers or microwaves. And now we're going to look at the third part of the question, is asking us if certain combinations of microwaves and printers can be carried on the trailer. And essentially what it amounts to is that if the point that it represents is inside this section right here, inside this this system of inequality solution that's been shaded green, if it's inside there, then it's capable of carrying those amounts. So we're looking at 4 microwaves and 2 printers for part C. So that's 4, 2. So is the point 4, 2 inside these parameters? 1, 2, 3, 4, 1, 2. It's right on the line. That was actually one of the points that we solved for with our first inequality. If we put in 4 for m, that's 4 divided by 2 is 2, times negative 3 is negative 6, plus 8 is 2. So 4, 2 is right on the line for our first inequality, and therefore it is inside this shaded region because these are inclusive inequalities. So the answer to this would be yes. The trailer can carry 4 microwaves and 2 printers. Now what about 7 microwaves and 3 printers? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. That's this point right here. That is not in the shaded region. In fact, they can barely carry 7 microwaves by itself, according to our second inequality. So the answer to this is no, we can't carry 7 microwaves and 3 printers on the trailer. And this would be a nice way to figure out what combinations of microwaves and printers someone could haul. So you're going to an auction and they've got microwaves and printers, and you want to know how many of each you can buy. You could set up this system of inequalities to determine the total number of combinations that you could carry on your trailer.